So yeah, I was invited to Tesla's AI Day.
What's your minimum specification?
If you need a RISC-V core for your solution, head on over to Sci5. They've got a wide range of vector and performance cores for your solution. This is so big, Sci5 is one of the players that helps develop the standards for the RISC-V architecture. It's so big, even Intel has skin in this game. Some of the leading AI companies are using Sci5's cores in their next generation products because they want something that's different to what's out on the market, slightly customized for their use case, and something with enough performance to drive home their solution. So if you're interested, head on over to sci5.com today. So to catch everybody up to speed, I did a video recently about Tesla's AI Dojo supercomputer architecture, from core all the way up to system, as we knew it approximately 2 weeks ago. Tesla had an AI Day last week, which I used that video to reach out and say, hey, if you're involved, can you ask to see if I can get an invite? And it turns out I have enough friends, thank you so much, that I was able to get an invite. Interestingly enough, I seem to be the only content creator there that I could actually talk to. You'll see this picture. This is the one I've probably used as a thumbnail. This is pretty much the only picture they allowed me to take while I was on site. Now, to put that further into perspective, Tesla's AI Day is not a marketing tool, it's a hiring tool. The whole purpose of the event is to hire engineers to tell them about what they're doing, how exciting it is, answer their questions, and hopefully hire them for the various roles that they need filling. It's very much not for press. So I was given, let's bring it up here. So I was given this, which is a yellow/orange lanyard and a yellow wristband. And that implies that I was either a content creator or an investor. This was also used as an indication for if an engineer sees these, they probably shouldn't talk to you. Because these are people who shouldn't be told potential information that is under NDA. So as a result, went into the show. Again, this picture was one that I was able to take. If we zoom out to the wide shots, this is just because I just gave my camera to some random person who clearly didn't know how to take photos. Going into the entrance, there was some food, there was some drinks, and then we sat down in the main area. Probably about 1,000 people showed up, plus about 400 Tesla employees. It was clearly an event that the Tesla employees was using to showcase all of their hard work and have a bit of fun at the same time. We sat down. Now, as press, I'm usually used to being in the front few rows. I was in the back few rows. We were literally organized into the last 10 rows of the event. And me being the short person that I am means that I ended up not really being able to see the stage and was actually watching the live stream on my laptop at the same time. And so were the investors who I was sitting next to. However, during the presentation, we had Musk and friends up on stage going through a lot of the AI-related technical innovation they've done in the past year. First up was the Tesla bot, or Optimus. We'll go through that in a second. Then we went on to some of the software aspects, and then Tesla Dojo, the AI hardware, which is what I was really there for. Now, we didn't learn necessarily as much as we learned last year with Dojo. If you refer to my other video, in that video we went from core to chip to tile to multi-tile to interconnect to interface processor to the HBM to the switching to the system to the rack. What Tesla did in this case was show more about some of the integration that was required. And they flashed up this slide, which is of their voltage regulator module. So typical VRMs, on a PC, you have anywhere from 8 to 16, or maybe 32 if you go in at the high end. These are anywhere from 60 amp to 100 amp phases, and they power the chip. Now, because on a Tesla Dojo tile, you have 25 of these D1 chips, you're looking at multiple kilowatts of power you have to provide. As a result, you have lots of these voltage regulator modules on board. Now, this as a board, it was a weird sort of 3D design. They had some that you could look at outside the presentation, and the whole point is that one of these units could supply 1,000 amps, and they needed at least 25 of these for the whole dojo tile. They're saying 0.86 amps per square millimeter, and because of how Tesla is cooled and how it's powered, you essentially have vertical power integration. And it was interesting to see that there were actually two types of this module that Tesla didn't go into, but I at least saw in some of the demos afterwards. This module, the one that I saw initially, was essentially a BGA package for the VRM on top of a BGA package and then built into the system, which I thought was weird. Then I saw one later on where it actually had a double height PCB. So essentially that sort of BGA on BGA was simply for making sure that everything lined up vertically. Now, Tesla did go into some of the issues they had with this VRM. It was failing, and as a result, some of the cores, some of the chips were dropping out, and it got to a point where they'd drop out often enough that they would actually have a critical failure. What Tesla said regarding this chip is that on board the VRM module, they also have the clock generator. And the clock generator is essentially a mechanical device that vibrates to create a signal, for lack of a better term. Normally on a main PC, this is kept away from the other components because it could be highly sensitive to electric fields, to magnetic fields. And in this case, Tesla found that it was actually sensitive to vibrations, the literal physical vibrations of having the power phases nearby. And they showed off this demo where the MEMS oscillator, the mechanical electrical micro system, was vibrating so much at the resonant frequency of itself due to the power delivery being around it, it was causing physical cracking in the oscillator over time. So as a result, they had to devise a way to put that oscillator in such a window where it wasn't at the resonant frequency and it wasn't being disturbed. So that was a nice insight into how they had to solve a problem with the Dojo system. Aside from that, we didn't really see much more new about the Dojo hardware itself. As I say, after the presentation, they had an area outside the presentation area where they were showcasing the Dojo chip. So I got to see the tile, I got to see the interface processors, I got to see the voltage regulator module, and also a mixture of the power delivery and also the SerDes connections from tile to tile. That bit was pretty impressive, and they actually had a full tile that you could pick up, and it's heavy. They were joking that if you guessed the weight of the tile correctly, you win the Cybertruck. I said it was in the region of about 44 pounds or 21 kilos, 20 kilos. They said it's actually more like 19 kilos, so not far off. Aside from that, aside from picking it up and it being the heaviest chip ever, I did joke that perhaps I need to do a compute per gram for April Fool's Day table just to see where it lies on the compute per gram graph. What they did have is one of their rack systems, or at least they had 3 of their rack systems. And inside an individual rack, you have 2 trays of 6 tiles each. These tiles are connected together through blue SerDes links. I'll show a video of Ganesh, who heads up the Dojo AI project. He's opening it up, and you can see 1 tray of 6 tiles, all connected with blue ribbons, and that's essentially your compute. What they don't have is all the pipes to go in to actually cool the thing. Underneath that rack of 6, is designed for 104 kilowatts and 120 odd kilograms. Under that, you have the Dojo interface processors. These are the ones that actually connect to the rest of the system through the switching. And then you have blades that power the interface processors. Tesla did say that they use 512 cores here. And if you do the math, 28 blades, that's 64 cores per socket, or 2 lots of 32 cores. Which means, either AMD or Intel in each case. I actually managed to get confirmed afterwards that they're purely using AMD here. So that's fairly interesting. And then underneath that, you have the power delivery just for that tray of tiles, and multiple power supplies in order to enable that. And then within each rack, you essentially turn it upside down, and then you have a second tray with a second amount of interface processors, second amount of AMD hosts, and then an Ethernet switch at the top. So that's how an individual rack is done, and they were showcasing essentially 3 half racks with the interface. And again, unfortunately, I wasn't able to take pictures. I was able to go around the back and see some of the cooling. It's literally all liquid cooled, or at least the power supplies are liquid cooled. The AMD processors are liquid cooled. It wasn't clear if the interface processors, the sort of network cards that do Tesla Transport Protocol over Ethernet, whether they were cooled. And then obviously the tiles are liquid cooled as well. So that was interesting to see. I wanted to poke fun, and every time I was getting too close to it, somebody was getting a bit nervous, and I'd ask questions like, what's the flow rate, and what's your temperature deltas between in use and idle, and I wasn't getting any answers. Essentially, if it wasn't done in the presentation, they weren't going to give me any extra flavor just by poking and prodding it. So what they were showing wasn't 100% new. We did get, again, some insights, and especially that MEMS oscillator fix. That was interesting to hear about, though they're still in the process of getting the thing ready to run. They say that they'll have a 4-rack system or so up and running by Q1, or maybe even one of the X-Pods up in Q1. And what a 4-rack system, so that's 12 times, so that's 48 tiles, is going to do is replace 72 GPU racks in their data center. Now, Elon says that this is, a multi-tiered process, but the point is that they want the teams to be able to turn off the GPU cluster and solely run on Dojo. So I asked what workload is first being transitioned onto the Dojo tiles, and they said some of their auto labeling workloads. So this is where you have data from the cameras and you want to be able to label it for what's a road, what's a lane marking, what's a car, what's a parked car, what's a bike, what's a building, that sort of thing. And it sounded like with multiple 8K cameras, you need about 10. It ran at about 0.1 to 0.3 frames per second, this auto labeling. So if you have, say, a 10 to 30 second clip, it was going to be in the region of several hours just to auto label it. So that's a pretty intensive workload, but because they have a lot of video data they need to label, it seems ripe for that sort of workload. I did ask about the comparison with, say, the Cerebras wafer. I know you guys have been asking me to compare Dojo to Cerebras. We did a little bit of that in the previous video, and I simply asked, what advantages do you have over Cerebras? What can you do that they can't? And they simply said it was a data ingest thing. So in order to, you need to put video data in at the right speed so you can keep churning through the frames. They said unfortunately the Cerebras solution doesn't have enough cross-sectional bandwidth in order to be able to do that. I mentioned in the last video that the Tesla Dojo supercomputer is only 3 tiles wide while it being 40 tiles long. 3 tiles wide because you have to still be able to get data into that central tile. It's only the outside tiles that have access to the rest of the network. And they were saying that even with a single wafer scale engine from Cerebras, they would have difficulty being able to stream the video data in for the compute. So it was definitely more a bandwidth issue than a compute issue, which is interesting to hear because those of you who follow the AI hardware space know that bandwidth and being able to get data in is half of the battle. So not much on Dojo. I do have to thank the team who stuck around and did listen to me, and those of you who put my name forward. You know who you are. I don't want to out your names on the channel. I hope to be able to see you all again soon. It was fun because at the end of the event was scheduled between 6 and 11, and I was actually able to have some shots with the Dojo team after 11, right before security kicked me out. And that's pretty almost literal. They basically turned around to me and said, right, you need to leave. And I was like, really? And they were like, yep, get your bag. And within 20 seconds I was out the door. So that's how kind of strict they were. They wanted to pack up as well, and they didn't want any non-employees on site. I was already over time, but it was the ability to speak with the people involved and the ability to get a little bit into their noodles to figure out how they're thinking was pretty good. I did ask a little bit about the next generation being a 10x speed up, but I didn't really get any more insights into that. Fingers crossed we get to hear more about the Dojo AI supercomputer as it builds out, as they actually start deploying internally. They did say they wanted to build 7 exapods in the San Francisco area to help run some of their workloads, though we are probably looking at a late 2023, 2024 rollout for that amount of systems. So that'll be beyond the next Tesla AI Day. Fingers crossed I get an invite. I'll put that out there now. So it might be good to see some of these workloads running on Dojo next time around, above and beyond what we already saw at AI Day. That was the Dojo side. I should probably talk about the Tesla bot, Optimus bot, because there are some interesting features silicon-wise involved there. Now, I won't rehash everything what Tesla said about the Tesla bot, or codename Optimus. You know, they're doing special hinge stuff. The ability to have what is almost 8 hours of battery life, or they said roughly the same amount of power that a human would consume in a day. Anywhere from, but at idle it'll be about 100 watts. When it's fully running, it'd be 500 watts. They showed some demos of it walking around and picking stuff up. On the day, they did the first untethered demo of the Tesla bot. So normally when you're testing it, you'd put a tether just in case it falls over. It was literally the first untethered test they did on stage of the Tesla bot. So I hear behind the scenes that they were worried it might not work, but it seems to have gone off without a hitch, which is a really good step forward. What was interesting, again, from a silicon point of view, was the brain. So Tesla have said since they showcased the Tesla bot last year that the whole point about building Dojo, about building FSD for the driving, is that you can apply it to many different things, especially visual workloads, such as the Tesla bot. So they're using similar sort of neural networks to help them do the mapping and the decision making and essentially what the bot sees as it goes through. Now, this bot, it was about 8-9 months into production, so the fact they're able to get it walking untethered is a miracle in of itself. I wanted to ask about whether they were working more from first principles or just going at it with machine learning from step zero. It's the sort of thing that any other company would spend 6 to 9 months actually doing a literature search equivalent before they even started, whereas Tesla seemed to have dived right in. Inside the brain, they said they couldn't use the standard FSD that they're using in the Tesla cars. What they're doing is they've created a separate, what they've called Tesla SoC on the system, and I'll show up the slide they put up, that is like the FSD silicon for the cars, but different. Do we get any more details than that? No, we didn't. Do I want more details? Yes, I do. Are we going to have to wait for those? Yeah. I mean, Elon said the goal of these Tesla bots is that they want them to cost less than 20K when they're in full production volume. The question is whether are they going to be 5, 10, or 15 years down the line. I mean, we've already seen robots from the likes of Boston Dynamics being the most famous one, do all sorts of things, but Boston Dynamics has been working on that for a decade, 2 decades even. And where their revenue stream is going isn't exactly clear. The whole thing from Elon here is that they want to build in volume at this low price to be able to help with menial tasks. And they had, some other sort of demo areas about how some of the software works relating to that on the show floor, with a lot of people going around saying, hey, do you want a job at Tesla? And I'd say, no, I'm a content creator. And they said, well, why don't you want a job at Tesla? That sort of thing. Though it was a fun day. It's a shame I wasn't able to take photo and video, even though there were plenty of people taking photo and video. I just know that as press, as a content creator, if I'd have taken photo and video, I would have got not only a slap on the wrist, but a bit of a blacklist. I'm not the one that they're trying to hire. They're trying to hire the engineers. So there is that to consider. Next Tesla AI Day, anywhere between August and September, I guess. Looking forward to it. Looking forward to hear what's coming out of it. Whether you like Tesla or not, either as a company or the people behind it, it's still interesting how they're pushing a level of innovation above and beyond what some of the other people in the market are doing. People have said that the Tesla bot isn't entering a market to disrupt it like the cars have been, so there might be some additional hurdles to overcome there, but I guess we'll have to wait and see. If you have any questions and I get a chance to speak to the Tesla team again, put them in the comments below and I'll see what I can come back with.